So we said we often use weak references to allow us to attach so-called metadata to an object. And again, an example being if we have a class that's marked as final and we can't derive from that class, we can't extend the class. And we tend to make this work with something called a weak hash map. So a weak hash map is like a hash map, except that the key is actually a weak reference to an object and not a strong reference. So the idea now is that the key is an object. Once all strong references to that key are cleared, then the key itself is removed from the hash map. So we store a weak reference to an object as a key, and then as the value for this key, we store this object's metadata. And again, I've placed this in quotes because this could be any extra data we want associated with this object. So when the object has no more strong references, the key is released and the object's metadata is also released. So something like this. Diagrammatically, we have a weak hash map here. We allocate an object. Again, we're using our person object, and we store a reference to that object inside the weak hash map. The key is held as a weak reference to the object, and then the value is held as a reference to this object's metadata. When we release the object, the weak reference also goes away, and at this point the value is also cleared, so the object's metadata also goes away. So let's see an example of that. So to show usage of a weak hash map, I'm going to create a class called person, and we'll mark this as final. So it's a class that cannot be extended. And then I'll create another class called person metadata. And in this class, I want to hold a date, and let's say this is the date of when the person object was downloaded from the internet. So we'll give our class a constructor, so we'll create a person metadata constructor, and this constructor will simply set the date. We'll say date equals new date. And we'll also add a toString method here. And in the toString method, we'll simply return the date that this person was created. So in main, I'm going to create a weak hash map. And our weak hash map is going to have a key to value. Now remember, the key is the object that we care about, and the value is that object's metadata. So the key will be person, and the value will be of type person metadata. We'll just call this thing weak hash map, and we set it to be a new weak hash map of person to person metadata. I can then do person, let's say Kevin, that'll be me, equals new person. And then do weak hashmap.put, and into here I'm going to put Kevin and new person metadata. So now I have a strong reference to a person object with Kevin, and I have a weak reference to a person object that's held inside this weak hash map. If at this point I do person metadata, p equals weak hashmap dot get, and I pass in Kevin, then that should retrieve the key. So I should be able to print out the person object. So just print out the person metadata. And we can run this and see what the output looks like. So I run the application, and there we see we get a person metadata object back. So now if I say Kevin equals null, so how do we prove this value is no longer in the weak hash map? We can't simply do weak hashmap.get now, because Kevin, which is the key, is now null. So it'll try and get a null value as the key, and there isn't a null value as the key inside there. So instead of that, we can use weak hashmap dot contains value. So if our weak hash map contains the person metadata as a value still, let's print out a message which is still contains key, and if it doesn't, we'll print out a message saying key gone. So if we run this code, then we see the key has gone. So by setting the key to null and then running a garbage collection on this thing, the key no longer has a strong reference to it. That causes the weak hash map to give up its weak reference on the object. And when that weak reference goes away, then the strong reference to the metadata is garbage collected.